notes. We started this on Thursday, and on Friday what we did is we just used that as a makeup day. So because a lot of people were out Friday, well, we didn't even have class Friday. So on Thursday we started these notes and we talked about transition metals. Right now we have left off that middle section, that transition metal section, because we've been talking about regular metals and just non-metals. We haven't been talking about groups 3 through 12. So transition metals, we talked about those are 3 through 12 in the middle. And we also talked about 3 things that we know about their oxidation numbers. The 3 things about their oxidation numbers is the first thing is that they can change because they're transition metals. You don't know their oxidation numbers. They vary, they change. The second thing we know is that they're always positive because they're still metals. Even though they're transition metals, they're still metals. So they're still going to give away electrons. So they're always going to be positive. And then we know that they have to be given to us as a Roman numeral. We cannot look at the periodic table and know the oxidation number for iron, which is Fe, which is number 26. We don't know it. If we look up there, we don't know it. It doesn't tell us anything because those transition metals, their oxidations vary. So they have to be given as Roman numerals, or we have to figure them out and we have to write them as Roman numerals. So we normally don't go over 6, so we went through 1 through 6 and just kind of did a crash course on what the Roman numerals are, 1 through 6. And that's what they are. So everybody's here, right? We put 2, we put these 2, correct? Okay, so let's just review what these 2 are. Remember what we did is we started just our steps. When we had iron oxide, we left the middle part blank so that we could put in our oxidation number there in a Roman numeral. We started by finding out the oxidation number for oxygen and then multiplying it, getting the charge for one side, and then working our way back around and figuring out what the oxidation number was for this iron. And that number is what goes in as our oxidation number, as our Roman numeral. That number goes in as our Roman numeral, okay? Then on this one here, copper, the same thing. We don't know our oxidation number for copper when we started off with. We did know it for oxygen. So we started here, we multiplied those 2 together, got -6. If this side's -6, this side has to be equal and opposite. So that would be +6. So I know I have 2 atoms of copper, so I could say, well, +3 times 2 is going to give me the +6. So that +3 is what becomes my Roman numeral because that's telling me the charge. So I'm going to give you your, so Justice, you're going to give everybody one of those. This is going to go in your notebook on the other side. So if you want to put this on page 57 or 56, depending on where it is. But we're going to start with some examples. You probably don't want to take this in until we're done because you're going to have to look back and forth at your periodic table. So we're going to start right here in the middle when you get this. We're going to start kind of in the middle of the page. You may want a scratch piece of paper to the side. I'm going to use one up here. As we go through. If you get lost with these, let's say tonight you're studying for your quiz tomorrow, there's lots of practice in here. We may not get to all the practice in class today, but if you get lost and you're like, I don't even know where to start, your steps are right here in these little word bubbles. So your steps, if you are given the formula in order to write your name, the name of it, you just have to read right here and follow those steps. And if you're given the name and you're going to write the formula, your steps are right here in this word bubble. So let's look at the first part here. We're going to start with, just like our examples were, of writing the name. So we have FeCl2. Thank you, ma'am. Yes. So when I go to write the name for this, there's 2 things I already know. I already know the elements, right? What does Fe stand for? Iron. So I know this is iron, and I'm going to leave my parentheses open because I'm going to fill it in with a Roman numeral. And chlorine becomes chloride. Now, I'm not going to say dichloride, again, because these are ionic. You do not use prefixes with ionic. So I've got iron something chloride. Now I have to figure out that something. That's my mystery of the day. So I'm looking for what goes in here. All right? So what I'm going to do mentally, when you get to the point, you may have to write these out a little bit, but you should be able to get to the point where you can kind of do these in your head. You don't have to show your work every time. But just to think it through, you divide it into two sections. That's the first thing. And this is where you start. You start up here at the oxidation number for chlorine, and you're going to do like a U-turn. You're going to work your way all the way back up to the oxidation number for iron, because we don't know that number, and that's the number we're trying to get to. All right? So what is my oxidation number for chlorine? I have to go to the periodic table. -1. So I have to take the oxidation number times the subscript to get the charge for this side. -1 times 2 is -2. So this whole side has a -2. If this side is -2, I know this side has to be a +2. So now I'm going to work my way back up. How many iron atoms do I have? 1. There's not a subscript there, so it's understood that it's 1. So now is the mathematics problem. What number times 1 is going to give me +2? 2. So this number is +2. So this number, as a Roman numeral, is 2. So this is iron 2 chloride. Iron 2 chloride. And that's it. You're done. So again, you're always going to start with your oxidation number for your nonmetal because you know it. You can find it and work your way backwards up to get your oxidation number for your nonmetal. I mean for your metal, your transition metal. All right, so here we go. Pb2S3. What do we know? We know lead and sulfur. So this is going to be lead something sulfide, and leave your blank because we're trying to figure that out. So in your brain or on your scratch paper, this is where your thought process comes into play. What is the oxidation number for sulfur? Yes, you do. It is a -2. You don't know the one up here for lead. That's the one we're trying to get to. Okay? So -2 times 3 is going to give me -6. If this side's -6, it's got to be +6. So what number times 2 gives me +6? +3. So if this is a +3, 3 is your Roman numeral that goes in there. Because you are wanting to know the charge of one lead atom, not both lead atoms. So don't put a 6 in there. You want to know it for only one lead atom. See the difference? Okay. All right, let's look at the next one. CO2O3. What do I know? Cobalt. That's right. I know cobalt and I know oxygen, so that becomes oxide. I don't know the Roman numeral. So when I divide it up, I'm going to start in this corner. What's the oxidation number for oxygen? -2. -2 times 3 is? -6. So if this side's -6, this side is +6. So what number? Yep, you got it. 3. Just like the one before. And you'll start seeing patterns like that. That a lot of it's, there's only so many charges and there's only so many electrons and everything's based on 8, and so there's lots of patterns you'll see repeating over and over again, and the more you do it, the easier it gets. And this is brand new to you, so at the beginning it may be a little confusing. It's not hard, it may be a little confusing, but it's not hard. All right, let's look at the next one. AgN2. What do I know? Silver. That's right, I know silver something, and when nitrogen bonds it becomes nitride. So go into figure out, start with the oxidation number of nitrogen. What is it? -3, right? Nitrogen is in group, what, 15? So it's a -3. So -3 times 2 is? -6. So this has to be +6. How many silvers do I have? So what does that number have to be?
6.
It has to be 6. Good. So 6 is your Vi. Each one's getting a little bit easier. And this is the hardest that they get, really. So, again, a little confusing, but not hard. All right. Zinc. Zinc something nitride. You know, there's only so many nonmetals. You probably have some of these memorized by now. We've done them so much. What's the oxidation number for nitrogen? -3, right? We just did one almost just like it. So -3 times 2 is -6. So this side has to be +6. This is 1. What's that number? +6. Just like it. Same pattern. Different elements, same pattern. So far, so good? All right. This one threw some people off earlier because the 2 is on the first one. But if you do it the same way, copper, not iodide, oxide. There we go. Copper something oxide. So Cu2O, split it up. Start at the corner here for oxygen. What's my oxidation number? -2. And this is, how many oxygens do I have? 1. So -2 times 1 is -2. So this has to be +2. So what's this number? 1. Very good. Don't let that confuse you. You do it the same way. That's +1. You're going to do a Roman numeral 1 up there. Excellent. And the last one like this that we're going to do together. What you got? Very good. You've already solved it. It is a 3. It is 3. Because chlorine is a -1. So if you think through this and you've drawn that little cross thing so many times and you put it to the side, your brain automatically starts recognizing those patterns. So it recognizes, oh, chlorine is a -1. So you think, oh, a -1 and I've got a subscript of a 3, so that's a -3 on that side, right? So this side has to be a +3. And I only have 1 chromium, so +3 is the charge. And you can work your way back up mentally without drawing that out. Do you want me to, did I mess up anybody? Want me to draw it out? We're good? Okay. Now, that's the hard part. I showed you that part first to show you how easy this is. Let's go forward. Let's, if I give you the name, this is so easy. And again, your steps are in the word bubble. So don't make this harder than what it is. I've had students all day long trying to make this harder than what it is. They're out there searching for the oxidation number of copper. And like my mama said, if it was a snake, it would bite you because it's right there as a Roman numeral. It's right there. Don't look any further. You don't need your periodic table for that. Because what's this copper's oxidation number? +2. It's given to me as a Roman numeral. Now sulfur, I do have to go to the periodic table. -2, unless you've got them memorized already. Then look over here. You crisscross them down and they become subscripts. That sound familiar? Same thing we did with the regular ionic bond. So if I crisscross those down and it becomes Cu2S2, can I simplify that? That's right, CUS. And that would be Cu1S1, and I don't have to write ones because they're understood. And that's what you do. So chromium, what's the oxidation? +1. You do not have to go to the periodic table. Nitrogen, -3. Crisscross them down. Yep. Cr3N. And you're done. Because 3-to-1 ratio will not reduce. All right. Cobalt, what's the charge? +2. Selenium, -2. Just like that first one, again, same pattern. It's going to be a 2-to-2 ratio, so that will reduce to a 1-to-1 when I crisscross them down. So how do I write that? COSE. That's right. Be sure on this one, well, on any of them, but especially on this one, capital C, little o for cobalt, because otherwise it could look like carbon and oxygen bonded together. So be careful with those, cobalt and selenium. So I didn't use that step like I did up here. I didn't write 2 to 2 and then reduce it because I just did that in my mental math. What's titanium's charge? Positive 3. What's iodine's charge? Negative 1. So what's my? That's right. Not negative 3, because your negative doesn't. Yeah, just when you come down with them, they lose their charges. Their charges go away. All right, so what's my charge for silver? 4, right? IV is 4. 1 before V. 1. And what's oxygen? Negative 2. So crisscross and reduce. So I heard Ag2O4. Can you reduce that? Ag O2, because a 2 to 4 ratio will reduce to a 1 to 2 ratio, and you're good to go. Right? Ma'am?
If we don't simplify on those, does it count off?
Well, yeah, I'll count a half a point off. On the quiz, I will. Now, and the important part is let's say it's EOC or a test. Ag2O4 may not even be an option. You see what I'm saying? So you got to know that it will reduce. And I doubt it would be an option because they would both be correct, just one wouldn't be simplified. Unless that's what they were testing for, but I doubt it. All right, so any questions? All right, so if you look on the inside, we've got a lot of practice. So we're going to do practice set 1. And what I'm going to do is I'm going to go to the back table with my answers and my stamp pad. When you get done, come back there to check your answers, and I'll check it for stamps for practice set 1, working on quizzes for your quiz tomorrow.